Hi, this video is about solving some quick math problems involving impulse and the change in momentum. So, if you recall, the momentum impulse theorem says that the impulse applied to an object is equal to that object's change in momentum. There are a couple of different ways to reiterate this same equation or the same problem. We know that the impulse is equal to force times time. And we also know that the change in momentum of an object can also be written as the final momentum minus the initial momentum. Furthermore, we could even go a step further and say the change in momentum could be written as the mass times the final velocity minus the mass times the initial velocity. So all of these equations basically say the same thing. What matters, though, is that you can set equal the impulse and the change in momentum. You can also know that impulse is equal to ft and change in momentum is equal to the final minus initial momentum. Those things are important to know as well, but just know that these two quantities are equal to each other. So let's look at an example with this. So here we have a 15 kilogram shopping cart being slowed down by a negative 250 Newton frictional force for 3.0 seconds. What is the impulse experienced by the cart? Well, we just talked about impulse is equal to force times time, Ft. Okay, and so that's going to be negative 250 newtons. Oops, I had an extra dot in there. Times 3.0 seconds. So you can put that in a calculator or you can just do it in your head. That is negative 750. And if you look at the units for impulse, it's newtons times seconds. Okay, so Newton seconds is the way we say this. And this is the common unit that we write for impulse because it's force times time, Newton seconds. This impulse is equal to the change in momentum. So for part B, it says what is the change in the cart's momentum, but it's the same as the impulse. It's negative 750 Newton seconds. Usually, though, we measure usually we measure momentum in a different unit. We do mass times the mass times the velocity, kilogram times meters per second. But over here we have Newton seconds, which doesn't seem to be the same, unless you realize that a Newton is a kilogram times meter per second squared. Remember, force, Newton, is mass times acceleration. So m times a, mass, kilograms, acceleration, meters per second squared. And if we have seconds still being multiplied by newtons here, if you look at the relationship here, seconds divided by seconds squared ends up canceling out one of the seconds, and we're left with kilograms times meter per second, which is the same as the momentum unit. So a Newton second is really the same as a kilogram times meter per second. Just a quick little technical detail there, that we can sometimes write these units as Newton seconds, or we can sometimes write them as kilogram times meters per second. So that's all I've got for you in this video. Remember, a bad attitude is like a flat tire. You won't get anywhere until you change it.